Hi everyone, we are looking at multiplying fractions and whole numbers today. We've done adding and subtracting so far, but I find that multiplying is a lot easier. If we remember, multiplication really is a shortcut for repeated addition. So 2 times 1/5, that's saying I have two of these things called fifths. So here is 1/5, here is another fifth. Altogether, I now have 2 fifths. Not too complicated. If we remember that multiplication is repeated addition, for example, 4 times 5 is really 4 of those 5. So it's 5 plus 5 plus 5 plus 5, which gives us 20. And that's repeated addition, which is a little bit longer than just knowing that 4 times 5 is 20. So when I have 3 times 1/4 modeled down here at the bottom here, that is 1/4 plus 1/4 plus 1/4 plus 1/4. 3 of those fourths. So you end up with 3/4. Also remember that I can turn any whole number into a fraction by placing 1 in the denominator. 3 over 1 is the same as 3 wholes. And now to multiply fractions, all I really need to do is multiply the top number, numerator times numerator, denominator times denominator. And I end up with 3/5. So if I have 7 times 1/9, it's really, if I'm turning it into a fraction, 7 would be 7 over 1 and 1/9. So I have 7 of these ninths. Now I could write out 1/9 plus 1/9 plus 1/9 and so on, but that's long. And it's a lot easier if I just multiply my numerators. So that's 7 on top. 7 times 1 is 7. And then 1 times 9 is 9. 7/9, and I'm done. Let's look at another example. So 3 times 3/4, or 3 of these 3/4. So it would be 3 over 1. I'm turning 3 into a fraction by placing 1 in the denominator. And then I have 3/4. And I have 3 of those 3/4. So it's a group of 3/4, another group of 3/4, and another group of 3/4. So altogether, that would give me 9/4. Now, it gets a little bit more complicated. When we don't have a whole number there, we have a fraction. So this is asking for what's 1/2 of 1/4. So here's 1/4, but I'm not asking for one of those 1/4 or two of those 1/4. I'm only asking for half of that. So what is half of 1/4? So it's only that part of 1/4 that I want. I don't want one of them. I only want a fraction of that one. So if I bring 1/4 back down here, and if I look at it on that scale with the whole one, I only want that part. And how many of those parts would make up a whole? And actually, it would be 8 of those. So if I turned each one of those fourths into eighths, and I'm only taking half of a fourth, it's only 1/8. And if I do the multiplication, which is the easier way to do this, but I wanted to show you the model anyway. So 1 times 1 is 1, 2 times 4 is 8, and we come out with our answer a lot quicker than drawing out the model or doing some kind of a repeated addition on this. So it's 1/8. So here's another model. So 1/4 times 2/5. So 1/4 of 2/5. So if you look at the model here, you look at the blue is representing 2/5 of this whole block. So you see two columns here that are blue, right? And that's 2/5 of one whole block. But now I only want 1/4 of that. So if I take that 2/5 and break it up into 4 sections and then shade in just 1/4 of that blue shaded in part, I end up with 2/20. Because now the whole box, the big square, is broken up into 20 sections, and only 2 of them I've shaded in here red, because I only took 1/4 of 2/5. So it's a very small fraction. So when we multiply fraction times fraction, we actually end up with a smaller amount. Just like in the last example, 1/2 of 1/4 became 1/8, which is smaller than either one of those fractions that we started with. Here's another one. Now this one, the numbers are getting bigger in our numerators and our denominators. So there is a way to simplify this before we multiply. Now we can just multiply it. If I just multiply 4 times 5, I get 20. And if I do the top, that's 7 times 15, which would give me 105. Well, that's a pretty big number, and it looks like I got a lot of simplifying to do. Top and bottom are both divisible by 5, so if I divide the top by 5, I get 4. If I divide the bottom by 5, I get 21. But there is a simpler way of doing this, and this is called simplifying before you multiply. So if I take that same problem, and if I look at my numbers on top, my numerators, and I look at my denominators, and I can find a common factor either right on top of each other or across from each other. And in this case, that 5 and 15 are both divisible by 5. So before I multiply, what I can do is simplify, divide each of those by their common factor. So 5 divided by 5 is 1, and 15 divided by 5 is 3. Now, I did not change these fractions into equivalent fractions. I'm simplifying the multiplication problem. So now I can multiply 1 times 4, that gives me 4. 7 times 3, that gives me 21. So now I didn't have to simplify. I went right from the problem right to the answer. So that's a helpful hint as we get with start using bigger numerators and denominators here. So here's another one where we can simplify, and we can do a lot of simplifying before multiplying. Of course, we can multiply 4 times 6 and get 24, and 9 times 10 and get 90, and then simplify from there, and that's absolutely fine. But you'll find with some practice here, this is going to be a lot easier. So I see a 4 on top, which is an even number, and I see an even number on bottom. Remember, the numbers have to be on top and bottom. I can't simplify the 4 and 6 together. So 4 is divisible by 2, so 4 divided by 2 is 2. And I'm also going to divide 10 by 2, and that's 5. And now I also recognize that 9 and 6 have a common factor of 3. So divide by 3, that becomes 2. 9 divided by 3 is 3. So now all I'm multiplying is 2 times 2, which gives me 4. 3 times 5 gives me 15. And it looks like I'm done. If you missed one of those, let's say you missed the 9 and the 6 had that common factor of 3, you could still do it, and you would have ended up with 12/45. And then you would have to recognize that both of those are divisible by 3, divide by 3, and you'd still end up with 4/15. Again, I'm showing you this because it will make your life easier if you start using that simplify before you multiply. All right, so here's another one, but now we have a negative number in there, and we can't forget our rules for multiplying and dividing two negative numbers. Now, we've done it with integers. It also works with rationals. So when we're multiplying two numbers with different signs, the answer is going to be negative. So this is going to be negative. I don't have to worry about that negative other than putting it in my answer when I'm done. So I can multiply this straight across. 5 times 3 is 15. 6 times 10 is 60. But then I'd have to simplify. But I recognize that 6 and 3 are both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So now 5 times 1 is 5. 2 times 10. Oh, there was another one I could have simplified a little bit more. So 5 and 20 are both divisible by 5, and that's going to give me 1/4. But I'm not done. Remember, I had that negative here. I had different signs in my original problem, so that gives me a negative answer here. Now, if I had recognized that the 5 and 10 were both divisible by 5, could have saved myself a little bit of time here simplifying. Divide by 5, divide by 5, and it would have been 1 times 1, which gave me 1. 2 times 2 gives me 4. And I wouldn't have had to do that extra step in there. All right, that's up to you. You'll start to recognize them a little bit more each time. So that's a brief introduction for multiplying whole numbers and fractions and fractions and fractions. Remember, for fraction and fraction, it's numerator times numerator, denominator times denominator.